Okay, now that we've learned about lists and dictionaries, let's learn about one more data structure for now. It's called a set. So sets are useful. They return all of the unique values of a collection. So think of it like a list, but only having one representation of each possible value in the list. So I can take a list or something like a list that has a whole lot of values. I can cast it or convert it into a set, and it will eliminate all of the duplicate values. This is really useful in data science to identify all the possible values of a variable. Help me identify maybe reducing the number of different values or expanding it. So let's go through some simple examples. Let's start with an X set. We're going to set this equal to the set function, which is run around. We're going to use some text. We'll put in spoon. Then let's make a Y set. The set function wrapped around soon. Okay. Let's print both of these sets now. And see what we get. So I told you this is for a collection. What I put in here was just a single word spoon. So what it does when it sees a single bit of text is that it acts like a split function and converts the characters into an array, converts the word into an array of characters. Then it goes through and identifies repeated characters and eliminates them. So it doesn't return them back in a particular order. But you can see here I have two O's in spoon. It returned SP, one O, and N. Same thing with soon. There's two O's, it eliminated one of them. So we have a few ways of comparing these two sets now as well. So let's print X set minus Y set. Whoops. Equals. No, not equals. Minus. All right. What do you get? So here's how this one works. It says let's take the X set first, whatever's on the left, and any characters in the next set, the one on the right, that are also in the X set, let's eliminate those and only show the ones that are unique across both sets, that aren't duplicated. So that results in just P because N, S, and O are all repeated in the Y set. Let's do another one. So actually, let me label this one first here. This is all of the elements in X set, but not in Y set. I'm going to call these elements, these are really objects. There we go. All right, let's print next. Let's do X set, and I forget what this is called. Is that the pipe command? I think so, the pipe. Pipe Y set. What this is going to do is return unique objects in X set or Y set or, whoops, both. Use my proper English there, my capitalization. Okay, so X and Y, unique across both. So it's kind of the opposite of this one. Rather than eliminating N, S, and O out of the list, it says, okay, across both these sets, what's unique? Well, there's two S's, two N's, and two O's. So basically, let's give us back this same set right here. It happens to be in a different order. It's just the way the function works. Don't worry about the order, though. So, cool. Now, that just happens to be, this isn't always the same as just printing out X because Y isn't always exactly the same as X. So, for example, if I were to put an I in there, this one now has the I, whereas this one doesn't because I is unique across all of them. So it's basically a way of saying, combine both these together into one big word and then redo the set function. All right, let me get rid of my I here. Last one, let's print X set ampersand Y set. And what this is going to do is give us objects in both X set and Y set. So only those that are in both. Actually, I'm sorry, this is really the opposite. Oops, the antithesis of this first one. Because what this one's going to return, let me show you, is rather than just the P, because it's the only one that's unique out of all these, it returns the others that are duplicated and eliminates any out of those two sets that only appear in one versus the other. So if I put the I in here again, I'm still going to have NSO for X set and Y set because I doesn't appear in both of them. All right. So that's the basic idea. Now, let's apply this to something more realistic. You're probably not going to use, well, I guess you could use it on a single word or string, but more often we're going to use it with a collection, some sort of list or dictionary. So let's do both. Let's start with an example of how to do this with a list. Then we'll do an example of the dictionary. So I'm going to copy and paste everything down there. Turns out it's probably not that useful because I want to use ages as my example. Let's do ages 1. This is our first set of ages. And let's plug in, we're going to do numbers for this one, like 18, 19, let's repeat one, 18, 21, 20, 21. Beautiful. Oh, and sorry, since I'm creating a list, I need to put my brackets around it, not parentheses. Okay, let's now make ages 2. And in this set, let's make them a little bit different. Let's do sums at the same, sum different. So 18, 20, 20, 18, 18, 21, 22. That'll work. All right. So let's call this ages 1 set. And sorry, I am already being difficult here. I don't use the keyword set there and there. If I'm making a list, I don't want the keyword set. I'm just putting together a list. It's down here where I use set. You can see set's actually a function. It uses parentheses instead of these square braces. And the function, I just simply pass in the list that's already been created somewhere else. So I can't simply type numbers separated by commas into the set function because the set function is looking for one and one object only. Well, ages is an object. Yes, it's a collection object, which is a group of other variables, but it's one name that I put in here. I don't put in the raw data separated by variables. So let's copy this one, and let's make our ages 2 set. And we'll put ages 2 into that one. So now we can actually just copy and paste, these names we used before. Ages 1 set, I'll copy everywhere that I used X set. Ages 2 set, I'll copy everywhere I used Y set. All right, so now this should work the same way. In the first set, I get each age distinct. Second set, each age distinct. 19 is, remember, with this one, with the subtract operator for between two sets, the order of these two matters. So in particular, although this set has 22, which is unique, this one has 19, which is unique, it's this set minus the values that appear in, minus the values that also appear in this set, and ignoring any values that happen to be unique in this set. Hence, it only returns 19. Now, if I'd flipped this, if I'd made it ages 2 minus ages 1, what would happen then? Well, instead of 19, it'll return 22, because now it's take this set minus that set. And it's going to return only the values that are in this set that aren't also in that set. Anyway, I'm going to go back to 1 minus 2 for consistency here. The rest of it works just like you remember up here. The only difference is rather than have a string full of characters, I've got a collection object. All right, let's do one more, and you get that it doesn't. These don't have to be numbers. These could be words in here, just like numbers. But if they're words, of course, I'd have to wrap them in quotes. So let's do one more example of how to pull from a dictionary instead of lists. It's not a whole lot different. I'm going to stick with no. I'm going to actually use heights as an example. So I'm going to copy a couple of dictionaries that are in your practice problems later in this chapter. I'm going to say this is height, a list of heights 1. This is list of heights 2. So you can see these are now in the dictionary example. If I let me go ahead and copy height 1. No, right here. I'm just going to change this one. H-E-I-G-H-T. Height 1 set. Height 2 set. Okay. So the way this works, though, I have to do this either with the keys or with the values. I don't do it with both. So what I'm going to do is cast this dictionary into a list. and I'm going to choose either to make a list of values or keys. So I don't access a dictionary with an index like I would with a list. With a list I can say, give me this age 21 right here because it's index 0, 1, 2, 3, 4, 5. Give me ages, square brackets 5, and that returns that value. I can't do that with a dictionary. Dictionaries, we access values using the key. So for example, well, I'm not going to go into that one for right now. So what this means is I've got to cast. Now, you learned casting in chapter, what was it? 2. When we casted variables, like for example, you can cast this 20 into a string 20. If this was a string 20, I could also, like this, hold on, sorry. Like this, I could also cast it back to an integer. I couldn't cast something like the word set into an integer because it's not a number, right? So there's only certain types of casting that works. Not all casts work. But with collection objects, I can cast. So, for example, if I wanted to just pull out all these values and cast those into a list, then I simply say list, and then I can put in height1 dot values open close parentheses. So that says dot values, as you learned in the prior 2 sections ago, returns just the values out of a dictionary into a list. So I can easily cast that into a list, and as we learned up here, a list can be set. So that's what I'm doing here. I'm setting a version of this dictionary that has been casted to a list to only include the values. So that's the same format I'm going to follow for the next one. We'll call this height2.values. Now I can go ahead and do my copy pasting. Use height1 set everywhere I have ages 1. Height2 everywhere I have ages 2. I wonder if I can have spaces there. I think I can. There, that looks more consistent, doesn't it? All right, let's run that. Here we go. Works just the same. So it's grabbed all of the unique heights, and in fact, they're all unique. However, are some of them the same across these two? Yes, there are. So there's 189 right here in both of them. So what happens then is, oh, there must be 2 of them that are the same. 195. Yep, there's a 195 here and a 195 there. So what happens is when I do height set 1 minus 2, I just get the 3 remaining only in height 1 that aren't in heights 2. Here I get all the unique ones all together, which is going to give me a total of 8, since I have 2 that are repeated. And then this one just gives me the 2 that are repeated. So that's it for sets. This is the basics of them. We'll use some examples of these later on in the course when we're doing some data understanding and some data cleaning.